Good morning or good afternoon to all my student friends. Let me welcome you all to my fourth video lesson on chapter 3 of physics. As you all are aware of COVID-19 pandemic, wash your hands regularly, avoid going into crowd and take healthy food. Stay home and learn well. Welcome to my fourth video lesson on physics. So in this video we are going to discuss chapter 3. Now from now on we are going to discuss a few video clips for chapter 3. Then only we will come back to chapter 2. Today in this video I am explaining work and power and also energy. A little bit of energy also will be touching through, and cases of work done. What are the cases when the work is said to be done, and how to derive relation between the SI and Cgs unit of work. And lastly we will discuss about work done against gravity. Now let's first discuss about energy before we go for work. Energy has many connotations. It is used to express different feelings. Like when you are tired, we said that we lost energy. When you are working, when you are very active, we feel that we are full of energy. And similarly, work and energy are closely related. Even they share the common unit. Now, we need energy to perform all kinds of work. Work cannot be done without any energy. And we derive our energy from the food we eat. And energy is defined as ability to do work. So this one we have seen in earlier class. Then SI unit of energy is joule, and the SI unit of work is also joule. Or when you sit and write something, you are writing homework or copying the notes, we say that you are working. If you say that you are working, then parents will agree. But in physics, if you are sitting and writing something, or if you are carrying something and standing, then physics will not accept as a work done. So for physics, work is said to be done only when the body is displaced under the application of force. In physics, work is said to be done only when a body is displaced under the application of force. So which means you to consider your work to be counted or said as a work done, you have to apply certain force on the body and displace the body to a certain distance. Then only your work is considered as a work done. So amount of work done is calculated using F d cos theta. F means force, d is a distance, and cos theta is a trigonometric ratio. Cosine is trigonometric ratio, and theta represents the angle. So that one we will see in detail next slide. So theta here means angle between the force and the displacement. Let us shortly discuss about trigonometric ratios. Now there are 6 trigonometric ratios, of which we will do only one now. We will see only one. Other 5 trigonometric ratios will be discussed later on in mathematics. There is a full chapter on trigonometric ratio, chapter 7. So there you will learn in full detail. So now trigonometric ratio. Let us see what is the meaning of trigonometric. Tri means 3. Gono means gonal means sides. Metric means measurement. So measurement of 3-sided shape or 3-sided figure is called trigonometric. Ratios means the fractions. Trigonometric ratio explains the relation between the sides. If you have one side and the angle, how to calculate the other sides, and if you have 2 sides, how to calculate angle. So these relations are explained through trigonometric ratios. And the trigonometric ratio is applicable only to a triangle with 90 degree. One of the side of the triangle should be 90 degree, or the triangle should be a right triangle. So right triangle is a triangle which has one of the side 90 degree, and trigonometric ratio is applicable only to the right triangle. Now in this case, our angle is here. Let us say the theta is our angle. Theta represents angle, and to calculate the trigonometric ratio we can use the cos theta, cosine theta, but in short we can say cos also because it is short form. So full form is cosine, C-O-S-I-N-E. Cos theta is b over hypotenuse. So b over hypotenuse. So b here is the adjacent side. We have 3 sides of a triangle. Hypotenuse is the longest side of the triangle. It is fixed all the time. Every time you go for the right angle triangle, the longest side will become hypotenuse by default, and other two sides can be adjacent or opposite depending on the position of angle. Now our angle is here placed at the lower next to B. Now the side B is going and touching the angle or hypotenuse, or the side B and hypotenuse is giving rise to this angle theta. Therefore B becomes adjacent. Adjacent means next to, which is close to us, and the A becomes opposite to angle. Now adjacent over hypotenuse is the relation to find this angle. And similarly, if we change the angle, now if we are taking angle to other side, only the letters will change here. Only it will become cos theta will become A over hypotenuse, but formula will remain same, because since angle has moved up, A will become adjacent side now, because A is close to the angle and B will become opposite. So this time B has gone far away, so B is opposite. Now always our formula will remain same, that is cos theta is adjacent over hypotenuse. Now let us see the cases of work done. Now I think with this little basic you will understand what is mean by angle. And to calculate in cos theta, you will have it in your calculator. Now what is work done, or what are the cases of work done? So how to remember the cases of work done? In your textbook they have given you 4 cases of work done, but here we are going to discuss 5 cases of work done, because generally there are 5 cases of work done. So work done can be positive, work done can be negative or 0. So these are the 3 conditions of work done. It can be positive, it can be negative or 0. Now firstly let us say the work done, when the work done will be 0. So work done is 0 here. Let us say the force is 0. If force is 0, work done is equal to F times D times cos theta, which means F is a force, and if 0 times D times cos theta, whole thing will be 0, because we are multiplying 0 to the number. So when you multiply 0 to any number, the whole thing will become 0. Similarly, displacement is 0, then also your whole thing will be 0. Now let's go for the example. You are moving on a frictionless surface. Let us say you are skating on the ice. Without applying any force, if you just slip off on the ice cube or on the ice without anybody applying force on you, then your force will become 0. Though you displace to a certain distance, skating on the ice or slipping on the ice, the whole thing work done will become 0, because force applied is 0. Then the second case, you are applying a large amount of force until you are tired to push a wall, but wall does not move. So in that case, displacement is 0. So force times 0 times cos theta will be 0. Now let us go for the theta angle. There are 3 conditions of angle, 3 cases. Let us see first one. When the angle is 0, so angle here means angle between force and the displacement. So what happens when the angle is 0? Suppose this boy is pushing a box in this direction. So his application of force is towards east, and the box moves towards the same direction. Then the work done is maximum and positive. When the angle between the force and displacement is 0, when this theta is 0, then we will have maximum work done. So angle between any 2 parallel line is 0. Now let's go for the second case. When the angle is 90 degree, this boy is suppose say applying force on the box, same box. Force is in parallel to his x-axis, or force is towards east, but body displaced in other direction. He is applying force towards the x-axis, but body is getting displaced towards y-axis. This happens sometimes when you play snookers. When you hit your cue ball to certain direction, the ball gets knocked into the other direction. Now here your force is applied towards the east, but body gets displaced towards the north side. Now angle between the force and displacement is 90 degree here. So this means angle between the force and displacement is 90 degree. So here cos 90 will be 0. Therefore the multiplication, now when you multiply this, force times displacement value will be there, cos 90, when you do cos 90 you will get 0, because cos 90 value is 0, and then when you get this from calculator, when you multiply 0 to whole thing, then again the work done will become 0. Then next thing is, in the first case, again you can also do calculate using calculator. When you put the value of theta as 0, you will get cos 0 will be 1. So force times displacement times 1 is always maximum work done. Then the third case, or last case, is we can also say it as a fifth case. You are applying force in inclined plane. Suppose say you are applying force upward, but because of the weight of the box, your box gets displaced towards the backside or in opposite direction. You are applying force towards x-axis, but your body gets displaced towards the other side. The angle between these two is 180 degree. So when the angle between the force and displacement is 180 degree, when you press this cos 180 degree in calculator, you will get negative 1. So cos 180 degree is negative 1. So when you multiply force, let us say force is having certain value, displacement is certain value, when you multiply negative 1, whole thing will become negative. So this is the condition where the force work done becomes negative, and it is not given in the book, but it is important to understand. I hope you have understood the 5 cases of work done. First case, when force is 0, work done is 0. Second case, when displacement is 0, work done is 0. And third case, when angle between the force and displacement is 0, work done is maximum and positive. And the fourth case, when angle between force and displacement is 90 degree, cos 90 is 0, therefore again work done is 0. Then when angle between force and displacement is 180 degree, cos 180 will be negative 1, therefore the work done will be negative and minimum. So these notes are already given to you 2 weeks back, so you can just go through this note again. Now I hope you will get a clear understanding on 5 cases of work done. So we will not discuss further. Now let us determine the unit of work. How to derive unit of work? If force is measured in Newton and displacement is in meter, these are both SI unit of work done. Force and displacement, both the quantities are measured in SI unit. Then the work done is measured as F times D, that is Newton meter. FD, it will become Newton meter, or the single unit to replace Newton meter is joule. So there is another unit, this is a substitute unit for work done. We can also measure work done using Newton meter. So now if the question is like this, derive a relation between SI and Cgs unit of work. So how do you do this? Firstly, you need to say 1 joule is equal to 1 Newton times 1 meter. So 1 joule of work is said to be done when force of 1 Newton displaces the body through 1 meter. So that is from the definition. Then 1 joule is equal to, now you are converting this Newton into Cgs unit, because our aim is to derive the relation between SI and Cgs unit of work done. 1 Newton is 10⁵ dyne. This one we have seen in class 9. And 1 meter is equal to 100 centimeter. So when you do this calculation, 10⁵ times 10⁵, when you multiply, it will become 10⁵. Then so 10⁵ dyne centimeter. So dyne centimeter here is the same unit, which is dyne has come from the force, centimeter has come from the displacement. and the combined unit is erg. Erg is a CGS unit. There are two types of unit. One is SI unit and other one is CGS unit. SI stands for System International Unit, and the CGS unit stands for centimeter gram second. And these are the smaller unit. SI unit is the bigger and the standard unit. And the relation between the SI unit, this is SI unit, 1 joule is equal to 10⁷ erg. So that is the relation. Now from here we can define 1 joule and 1 erg. So 1 joule is the amount of work done in moving a mass of 1 kg through the displacement of 1 meter on applying force of 1 Newton. So this is the definition of 1 joule. Similarly 1 erg. So if you just remember one of this definition, you just need to replace 1 joule by 1 gram, 1 meter by 1 centimeter, 1 Newton by 1 dyne. So let us read it once. 1 erg is the amount of work done in moving mass of 1 gram through displacement of 1 centimeter on applying force of 1 dyne. That's all. I hope you will remember it later on. So work done against gravity. So that is our next topic, next subtopic. Earlier we learned that the work done is force times displacement. So just below this, before this slide, we learned that. So if the body is falling against the gravity, then this D has to be replaced by H. So D will be replaced by H. Now there are two types of displacement. One is D. When you use D is, suppose a car is moving on the road or ball is rolling on the ground. So we are measuring the horizontal distance. So there we usually write D, distance. But H represents height. If something is falling vertically from the top of the building, or something which is falling against gravity or towards the gravity, we represent D by H. And the force, usually force is written as mg, because we also have learned that F is equal to ma in class 9. Force is equal to mass times acceleration. So here this A is when you apply a certain force, you kick a ball. When you kick a ball, by applying force, ball moves, ball has certain mass and it moves with the acceleration. So when you give that product of mass and acceleration, we get force. But here nobody is kicking the ball, but the force is applied by gravity, and that gravity will let the ball accelerate downward with the value of 9.8 meter per second square. So that is why we are replacing this, we are replacing the F by mg. And when you replace F by mg, we get W, work done against gravity, is mgh. Mg here means force, h is D. So work done against gravity is calculated using the same. Now let us see calculation of work done. Let us see example of work done. Now here we have got tandem. So tandem is pushing a box or rock of mass 300 kg through distance of 3 meter with a force of 250 Newton. The rocks moves along the direction of force. Calculate the work done. Now this question has given us certain things. What are the given thing? Let's see. We are given three things here, important things. We are also given, which is not required, that sometimes it might distract you, but you have to choose. Once you are used to with the formula, you will know which the quantities are important. So now you don't have to consider this. Given force, because we know that work done is F times D times cos theta. We need force. Force is 250 Newton. Displacement is given 3 meter, and the rock moves along the direction of force. So here along the direction of force means angle between the force and the displacement is 0. Theta is 0. Then what you do next? The formula is FD cos theta. Then F and D you can replace the formula. You can replace by number. F is 250, then 3 displacement is 3. Then you type cos 0 in your calculator. Cos 0 in your calculator, you will get 1. That value is substituted here instead of cos. Then when you do this 250 times 3, 25 3 is 75, then times plus 1 0 is there, so it will become 750 Newton meter or 750 joule. Now let's see the second question. A crane is used to load or lift the big metal bar to the top of the roof. A crane lifts 800 kg metal bar to the top of 7-meter tall building for roofing. If the value of G is 9.8 meter per second, what is the work done by the machine? Now, since G is given, or even looking at the nature of work done here, you will understand what formula to use. In the previous case, he is applying force and the force is moving the body horizontally, displacing the body horizontally. And here, force is lifting the body and it is lifting against the gravity. Now we are asked to calculate work done against gravity. Now when you calculate work done against gravity here, so we have to use the second formula. We are given mass is 800 kg, value of acceleration due to gravity is 9.8 meter per second square, and 7 meter is the height. And we also know that formula is mgh. So when you substitute the value, mass is 800, 9.8 is g, and height is 7 meter. Then we have got work done of 550 or 54,880 joule or Newton meter. Now, which means once that bar is lifted to height of 7 meter, it will have the potential energy of the same 54,880 joule. So if it falls back, it will do the work of 54,880 joules. So these are the two examples of work done. I asked you to practice example 3.1 and 3.2 given in the textbook. You must have gone through it. So thank you for watching. Eat healthy, stay safe, and take care of your junior siblings at home, and help your parents in household chores. So if you feel that the video is useful, share with class 10 friends of other schools, which might benefit them. In the next lesson, we are going to see power of machine, efficiency of machine, and the calculations related to efficiency. So thank you, stay safe.